and welcome to Predict the Unpredictable, a webinar by iNatrix on making predictive maintenance work for you. I am Annie and I will be moderating this session. We are bringing you this webinar as a response to several interesting questions we have received, and we hope that by the end of this session, you will have a better understanding of what predictive maintenance is, how it can benefit your company, and what should be the roadmap to implement it. Before we begin, let's just take a look at how this webinar will be structured. In a moment, I'll give you a quick introduction to our company, as well as our speaker for today. Our primary focus is you and your needs, which is why we will be keeping this webinar interactive. Through the course of the webinar, we will be taking a few audience polls to get a better understanding of your needs. If you have questions along the way, please feel free to use the GoToWebinar panel to message us your question via the chat box, which we will answer at the end of the webinar. We would also love to hear your feedback. Do mail us at feedback@iNatrix.com to know your thoughts. First off, a little about iNatrix. We are an agile software services company based out of New Jersey, with over 100 employees at our head office. We also have a solutions division in Bangalore, India, with over 270 employees and counting. We cater to clients across the globe, from the United States to Europe and the Middle East. While we work on a number of different technologies, our key focus areas are artificial intelligence, machine learning, the Internet of Things, and robotic process automation. Our speaker today, Vinay, is our Chief Data Scientist here at iNatrix, as well as the founder of Ocean Frogs, an analytics company. He has a doctorate in airline crew scheduling and has extensive experience in working with predictive maintenance, primarily on turbines and windmills. With that, I would like to request Vinay to take over. Over to you, Vinay.
Thank you, Annie. Welcome, everyone. It's a privilege to talk to you today. I'm going to talk to you about predictive maintenance for next 25 or 30 minutes. Now, in this discussion, we'll talk about what the benefits of predictive maintenance are, when it should be implemented, how it should be implemented, what should be the roadmap for a predictive maintenance program, what are the type of cost savings that we could do using predictive maintenance or asset maintenance program. We will also show you a few use cases in industry where we have worked. To move further, we would like to ask you a question. You could take this opportunity to respond to the poll that is presented on your screen. Thank you for wonderful responses there. Let's begin. And so the first thing we are going to talk is that why predictive maintenance? What are the benefits of predictive maintenance? Well, there are various reasons why predictive maintenance is of interest to stakeholders these days. One of them is root cause analysis. What are the causes of failures? Why do machines fail? When do machines fail? This is of increasing interest to customers or manufacturers and stakeholders, various stakeholders, because everybody wants to minimize the downtime cost. So downtime cost also is of two types. Either it's because of the machine that is down, or it's also because of the crew schedule or the maintenance schedule that everybody wants to minimize. So either you can optimize the maintenance schedule and save money there, or you can minimize the downtime cost of individual machines or product lines and minimize the cost there. Another use case that is very popular is with the manufacturers, such as for turbine manufacturers or windmill manufacturers, is what is the warranty cost or what is the impact on warranty cost due to unplanned outages. Everybody knows what the impact on warranty cost is of the planned outages, but the main component or the main contributor to cost warranty cost is the unplanned outages, and that's why research in the last 30 years have focused on unplanned outages, and that's why many manufacturers have collected a lot of data on historical failures and parts and have been building models for warranty cost. Not only that, but it also helps the manufacturers tell their customers when should they repair, when should they replace, upgrade parts. It also helps manufacturers tell their consumers and customers that what should be the term and condition contract that they should sign for, and that will be the best for their users. Now, obviously, no matter what predictive maintenance objective you have, you always you always get some more insights, such as what are the equipments that are behaving different compared to other equipment, or what are the products that suffer more downtime compared to other product and equipment. So just by collecting all the data and laying a good foundation for predictive maintenance or asset maintenance, these are the benefits that you will start seeing immediately. Now, for the next few minutes or slides, we'll talk about that what data should we collect and how can we utilize that data. And to move further, to go there, again, we would like to talk about that what are various use cases again in the landscape of predictive maintenance or asset maintenance that we talk about. What are the objectives that people have when they think of implementing predictive maintenance? So now again, there are two broad scope or objective. Either one wants to minimize the downtime, another is you want to calculate your warranty cost. If you want to minimize the downtime, either you want to minimize the maintenance cost or maintenance scheduling cost, or the system is dependent on reliabilities and you will want to maximize your uptime. Your customer wants uptime, and that's why you want to minimize the downtime. But if you're driven by warranty cost, most probably it's because you're a manufacturer of an heavy equipment. In that case, generally the use case is that you want to accurately estimate what the warranty cost should be, because the warranty cost is there for 10 years or 30 years. In case it's a turbine or a windmill, the contracts will go for that long. And you will want to not only know that what are the unplanned failures that are coming often, but the main purpose to know that is because you want to estimate the warranty cost. And while you do that, obviously you also want to know what is the root cause of failures. What are the parts in the turbine or windmill that is causing the failure? So as I said before, that it's always very important to identify what your goals are. Is your goal to identify the warranty cost or minimize the downtime, or to measure what your reliability is, to minimize the maintenance cost, or to minimize the maintenance cost of your crew, or even to minimize the cost related to your field folks, people who you assign maintenance tickets to. So it could be either one of those goals. Sometimes it's more than one goals also. Now, no matter what one of those objectives are, we always have to identify the failures. Now, the difference, why do I say that we have to identify the failures? Because there is a difference between failures and error codes, or sometimes we also call it fault codes. So you have to do a mapping between failures and errors. You also have to identify what your parts are and what is the mapping between parts and failures and error codes. Now, once you do that, you have to identify, let me show you some more content there so that it will make more sense. So now, as I was talking about identify the failures, now there are tons of failures that could be related to an aircraft engine or to another heavy equipment, because there are, hundreds of thousands of parts sometimes. And sometimes the error codes that are coming out of there are also a significant number. it's not easy, or it doesn't make sense to identify or analyze every failure there and to develop a simulation model or a predictive maintenance model on every failure. So you have to choose the right failures that you will want to build your model on. And it's not a one-day effort, it might be an iterative effort too, but either you have to use a Pareto law to figure out what are the failures that cost you the highest amount of downtime or downtime cost, or you have to do failure mode effect analysis and figure out the failures that you will want to invest more into. Now, to do that further, you will have to calculate a few statistics, and everybody knows those statistics, and a mean downtime or mean time between failure, mean time between failures of critical events. All of those things are that should be put in place, and that should be put in place accurately before you become more ambitious. Now, having said that, having known that what are the parts that are responsible for failures, what are the failures, what are your KPIs, what are the values of your downtime and mean time between failures, that will take you to a stage where you can say, yeah, now I'm ready to identify the root causes of failures. Once you do that, once you know what your failures are, now you're in a position either to optimize your schedule, to develop an optimal schedule, or you will have enough historical data and you will have laid out and a good foundation of predictive maintenance that you can say that now perhaps my statistical models will tell me in an estimate manner or approximate manner that when is my failure going to be. Now, some people do this exercise so that they will know that what is their system reliability. Now, system reliability is a pretty, though we all think it's pretty high level concept, and it is right, it's a high level concept, but people have to answer to their customers and their stakeholders that what is system reliability. And generally, people always relate system reliability to downtime or uptime. One thing that we generally miss or sometimes miss is that system reliability should always be related to what your SLAs are. So what is service level agreements that you have promised to your customers. And so now service level agreement, either it could be an actual SLA or it could be a promised SLA. It's always important that you relate it to your system reliability definition. For example, in case of Microsoft Azure, if you go to subscribe them, we will think that their definition might be related to downtime or uptime, though you will see that the Microsoft Azure promises that 99.9% of time the transactions will succeed. So instead of defining their definition of reliability by downtime or uptime, they are doing it not only by downtime and uptime, but also by number of transactions. So so in most of the cases, what I have seen is by working for bank ATMs or for electric charging stations industry too, that it's a combination of both of them, downtime and uptime, and at the same time, the number of sessions or number of transactions that they should be related to system reliability. Now, system reliability should sometimes people do consider planned downtimes also there, and other times they don't. Now, though it's insignificant whether a question that whether we should include that or not. It's a question actually. The question that you have to answer is that who are you going to show those numbers to? If you are going to use those numbers internally, perhaps it makes sense that you separate out planned and unplanned downtime so that you will have a better sense of that how your system is behaving. But to the outside world, it makes sense that you show one number there, and it's up to you to decide whether you want to include planned and unplanned downtime there or not. Now, on this journey towards predictive maintenance, and it's a long journey, you have to start with that what are the parts that are failing? And not only that, what stage do they fail at? Do they fail early, when you have started the transaction, or do they fail later in the transaction? And where the transaction is defined as when a user or a consumer or a stakeholder starts to use the equipment that you are using. Not every heavy equipment or not every asset will have transactions. Some of them, such as ATMs, will have transactions or sessions. Electric charging stations or gas stations will have sessions and transactions, but not every heavy equipment will have detection stages. And but each one of those equipments will have causes of failures and error codes. And sometimes the failure and error code might be directly mapped to each other times it not. Sometimes error codes might tell you that this or that part is responsible for failures. Other times, one error code might be related to many different parts. It's also possible that part A is responsible for the failure of part B also. So all those cases will come up, and those are the cases or those are the scenarios that one has to resolve before we say that, yeah, we are ready for predictive maintenance. Now, once you have done that, once you have come up with a mapping between parts and failures and error codes, and also have figured out that what are the actions taken for them, and then you have to figure out whether this failure did it result into downtime or not. If it did, how much was it? Sometimes it's just not easy to figure out that, oh, 15 minutes was the downtime because of this failure, because there could be many failures one after the another, or it could be that more than one parts were responsible for it. So one has to analyze what was the downtime, or maybe you have to reach to a stage where you can calculate the mean downtime to be able to say that, yeah, this much downtime was responsible because of that failure. So now there could be many actions though. So now an action could be that it was a replacement event in case of a failure, or it was a repair, it was an inspection, or it was an upgrade also. Sometimes because of the business rules, when people go to replace a part, they end up upgrading it. So there might be many actions, and sometimes there is no action also taken. Sometimes there are error codes that are just information related error codes. And so you will have to identify that. When I did it for electric charging stations, we talked to all the manufacturers, and we identify the error codes that are just information level or error level, or the ones that are severe. We categorized error codes into various categories, and we were able to identify the error codes that are responsible for failure and that are causing severe downtime. And as soon as we identified the failures and error codes that are responsible for severe downtime, and we saw that there is a significant number of them, and initially we just focused on those failures and error codes.
So while Vinay takes a breather, we have two questions for you. Let's just take this moment for a quick poll. Here's the first question. Thank you for your responses. This is the second question.
Thanks for your wonderful responses there. We were talking about what are the various data points that one should collect. Now, there is another important exercise that's time consuming in this journey of predictive maintenance is that what should we do when we have all that data? Well, as I said before, not every failure should be considered towards predictive maintenance. Even if you are going for warranty cost model based approach, or if you're going for root cause analysis approach. Now, though it depends on, in case of warranty cost model, obviously, because people do tend to simulate failures, and as a result, there is a significant computational power that goes in simulation of those failures, and that's why it's important to minimize or keep the number of failures in limitation. Now, let's consider that. Let's consider that you don't want to choose all the failures and you want to pick a few. Now, in case of turbines, what we saw is that if we had approximately 10 to 15 failures, and we identified those failures out of hundreds of them, but we saw and we observed that they were contributing significantly to the downtime and to the cost of maintenance. So in other words, what we are saying is that even by limiting our modeling approach to 10 to 15 failures, we were able to estimate and forecast what our unplanned cost is going to be for next few years. We were able to simulate for every year for the rest of the life of the turbines and do that. Now, how do you identify those failures? Well, the first is you have to have data about failures to be able to analyze them. There are some failures where it's not easy to get data, such as external failures or failures driven by external objects or external events. It's not always easy to get data about them. If you cannot get data about them, what could you do? Either you put a practice to collect the data, but if you are on the journey to it and you have rest of the data, maybe you want to see whether rest of the data is enough. Now, if you have significant data about failures, you want to see that how many devices or how many equipment is this failure incurring or occurring into. You also want to see whether what is the downtime cost or what is the impact of this failures on other failures or other parts. Is this failure universal? Is it occurring, irrespective of the type of part you are installing? So all of those questions will help you identify what are the failures that you should incorporate. Generally, if you are going to, if you have historical data and rich historical data after cleansing and transforming the data and after doing failure mode effect analysis, you will want to see whether that historical data fit into any statistical distribution or not. Some statistical distributions are more famous, such as Bernoulli or log normal distributions. They are more suitable and they also are more friendly in statistical analysis and in simulation studies too. So if you're lucky and you find that your historical data do fit a statistical distribution, then that's a really good success story there because you can build your predictive maintenance model on top of that. And generally it is observed in warranty cost model. In root cause analysis model, though you might have to take another approach. But the good thing in root cause analysis model is that you do not depend on 5 or 10 or 15 years of worth of data. You could do it with the equipment log data also. And because equipment log data might be coming every minute, every day, and so even 2-3 years worth of data might be good enough. So it depends on the type of use case that you have, whether you want to go to fit a statistical distribution or do you want to find root cause analysis. Now, irrespective of, again, what the use case is, you will always want to know what is the operating profile of your equipment. Now, in case of, in case of electric charging stations and turbines and windmills, it was always easy to get what is the operating profile. Some people also call it load profile or load operating profile. So what is the operating profile of my equipment? How many times, how many cycles, how many hours has it been already run? So the unit of measurement could be different depending on the type of equipment, but you're always, you could understand it by saying that what is my load operating profile? So one is what is my actual load operating profile? Another is what is my expected load operating profile? Some companies and some clients, we have also seen and we have implemented forecasted load profile. That what do I think that how much will be the uses in future? Because that's what I will give to my simulation models or to my analytical models. And but forecasted load profile again will be more used in warranty cost driven approach, where you want to know what should be the warranty that I should charge my customers or my equipment users. Now, these are the basic KPIs or statistical measures that you should calculate when you go on this journey. And it's one thing to calculate them. It's another thing to have confidence in them. And the confidence does not come on day one. So when you have confidence and when you know that you can live with these numbers, then it's time to go on predictive analytics journey. Until then, even if you do business intelligence on these data and all the data that we showed before, such as parts and failures and detection at stage and action taken, that will give you more insights than investing time in predictive analytics. So this is a foundation that you have to have more confidence before you go further. Now, there's one more here is a mean time between critical failures. So remember I was talking about electric charging stations, and there were many error codes there, and there were many error failures there. So what we did is we limited ourselves to critical failures. We identified critical failures, though, again, based on either the feedback from the manufacturers or based on historical data observations that what are the failures that are coming more often or what are the failures that are costly. And we utilized those and calculated mean time between critical failures in electric charging stations. And why did we do that? Because that gave us quick insights by analyzing the data. Now, so if I combine it all together, what do I have to do? First, I have to define what is my objective. And second, I have to define what is the definition of uptime and downtime and reliability. If I have a system, if I have a network of devices, what is the definition of reliability? Is it related to uptime and downtime only, or is it also service related agreements? Once I have the definition right, I also have to gather some other data, such as what is the operating profile of my new equipment and old equipment, what is their retirement age, when are they expected to retire by plan, what has been their maintenance history, what is their inspection history. Most of the time we do see that the maintenance history or the work orders, they are there, but they are not consolidated, cleansed, or not ready to be used. So even that took a lot of time for us to be able to use that in our models. Once you have done all that, on the other side, you have to identify, you have to categorize your faults. So we can perhaps call it a fault classification exercise. So in that exercise, you have to identify the parts, the failures, the error codes coming from machines, the services also. Sometimes it's not part that will result into a failure, but it could be a service that will result into a failure. And what are the actions taken into the all of that will help you come up with the attributes that related to the failure. Now, having known what the attributes of the failures are, first thing is to go to statistical measures and calculate or figure out what is the frequency of the failure, downtime, mean downtime, all those basic things that we have been reading since 1990s. So, now, in this exercise or homework, when we get ready to do predictive maintenance, there are some failures and faults that will be in the scope. And why? Because they are related to the downtime or to the warranty cost. There will be some parts that are the cause of failures and faults, and sometimes there is one part that is the cause of many different failures. So you have to do all those mappings before you go further. Mapping between actions and failures also have to be done. And also, like in case of electric charging stations, we saw that some failures were related to voltage, other failures were related to current. And some other failures that were not related to any of those, but were related to the external user who is using the equipment. So you have to identify the measures related to it and why is that failure coming? Is this because of external event or internal event? Again, as I said before, not every fault results into a failure. The number of faults might be in thousands, while failure one should limit it to a few. Also, we have to keep a differentiation between a planned maintenance outage and an unplanned maintenance outage. It's a very tricky. Sometimes when you go there, because there is an unplanned outages, and you end up also doing a planned maintenance outage because you want to minimize the on-site inspection cost. Now, have those been recorded right? If they have been recorded right, things will be so easy for you later on. Another good approach that I have seen in some of our project is that we were able to identify the severity level very early in the project, and that helped us because we all want to get some benefits quickly. Obviously, also, if failures are covered in terms and conditions of warranty, I've seen that clients behave differently towards those failures. Now, so the question is, what is the objective? Why are we going on this journey? And definitely, it's not a short-term journey. We all know that data collection, data consolidation, data cleansing, coming up with the right failure attributes will take time. And then building a model, predictive model on top of that will not be a one-day journey, though. So it's very important to know that why are we doing it? So what we have seen is that the manufacturers have different reasons, and network operators or users of equipment, they have different another reason. So either if you're a network operator and you have a warranty cost given to you by your manufacturer, you'll want to know whether I can negotiate warranty cost for another contract or not, and you could run a predictive maintenance model. In all of these cases, you will need certain data. In case of warranty, you will need to see that what is the historical data that you have, what are the failures that are coming more often than others. If there are certain failures that are coming more often than others, you will want to have a warranty of those. And you will want to apply various terms and condition models also on those. If you are a railroad or an airline, you will want to do two things. You will want to minimize the downtime, obviously, and not only that, but you will want to minimize the crew cost, the maintenance crew cost also. So the good thing for airlines and railroad in this case is that if they want to minimize the cost and the downtime, they don't depend a lot on historical data. As far as they have business rules and information about their assets, they can run an optimization models. So the benefit of optimization models is you don't need tons of historical data. So again, one can go through the slide, but it depends on the stakeholder, and every stakeholder has unique objectives, and that's how the predictive model or the roadmap should be decided.
We will now be having our last two poll questions for this session. Here's the first. Thanks for your responses. And the final question of the session should be on your screen right now.
Well, let me take you through some specific use cases that we have implemented with our clients. So first one is the electric charging stations. Now, electric charging station industry is coming up very well. We did one project where we are helping our client implement predictive maintenance roadmap and then go further from there. They have 2,400 electric charging stations in California and US and then on Eastern region too. Now the devices are such that they send the logs or they send a status of their health every 15 minutes or 9 minutes also. Sometimes it's a configurable. They do send information about their health, about the statuses, the error codes also. If there is an error on their side and if they are alive, if they are connected to the network, they will send that error code. When they do send error codes, those error codes are according to the protocols or according to the standard protocols available in the industry. And as a result, we do know that what are the parts, detection stages, and services or error codes that they are related to. And we also did all this, the survey with the manufacturers and figured out that what are the action taken on those error codes, what are the detection stage also, we got it from the manufacturer, what is the specific part, such as the cable that those failures are related to. After that, we identified the downtime, uptime, system reliability also we had to define because as you could see that similar to Microsoft Azure, they also have transactions and sessions. So it's a little bit different from turbines, use of a turbine. Turbine might not have sessions or now what we found is that for most of the manufacturers, of electric charging stations, we observed that external factors were causing more downtimes or more faults or failures that were related to significant downtimes. And why is that? Perhaps because it's an upcoming industry. We observed that cable that is used to plug into the electric vehicle, cable related failures are coming more than other failures. So we were able to identify the sites, the equipment, the devices where cable breaks down more often than others. We were able to specify or identify the failures and error codes related to the cable that were coming more than others. And we were able to take proactively preventive action to solve those problems. And that in itself helped us save downtime a lot or reduce downtime a lot. We'll also like to tell you about another client that does manufacture automobile components in India here. And the client has significant high setup time because they have significant number of product and product lines. And as a result, production schedule varies significantly, and perhaps as a result, downtime also changed significantly. But because of variation in the downtime or because of unpredictability about the downtime, it's not easy for them to promise to their customers what the production schedule will be, and they are not able to adhere to their SLAs on production planning. And at the same time, client is implementing an ERP, so they are in early stage. What we did is we helped them put right KPIs related to asset maintenance for them. Once we did that, we analyzed what are the root causes for their system, for their product lines, and identify what product lines, what shifts have significant downtime compared to others. Once we did that, again, the client was able to take action on it and were able to reduce the downtime. One more engagement we are involved in is for aircraft engines, where we have got the data from sensors of aircraft engines. We also have information about the error codes, about the failures of various different engines, where engines have varying age of aircraft there. We put it all to our engine here, our machine learning engine, not the aircraft engine, and we were able to utilize it to tell what is the remaining useful life of the aircraft engine. And we were able to tell them that when will aircraft engine and its components will fail and with what probability. Though Having done that, passing it through that data through our machine learning engine, we were able to identify the engine IDs that have higher, that are more prone to failure or to retirement early, as you can see in the first picture on this graph. We also put this data to our Power BI tool. We use Power BI here and show that where those aircrafts are at a certain point. We were able to use that to figure out that what are the engines that are at critical stage and what are the engines that are not at critical stage but at an okay stage. We are also showing you there on the dashboard that what are the parts and how many failures do we have for each of those parts if we look at it at an aggregate level. So once we do the machine learning part, we send all the data to our Power BI tool or any other visualization tool, and that is used to visualize and aggregate the data and show various KPIs. At this time, well, we have talked about how should data be stored, how should data be collected, what are the objectives and benefits. I think it's a good time that we can let you guys ask a few questions.
Thanks so much, Vinay. We will now be taking about 10 minutes to answer your questions. And as I can see, we've already received a few questions over the chat, which we will be addressing in just a moment. But if you have any questions that you've been holding on to, you can still message them to us. And if you would prefer to ask them aloud, what you could do is you could click the hand icon in the GoToWebinar panel to raise your hand, and we will unmute you so you can ask us your question. All right, so Vinay, we've got a question over here that says we don't have thousands of devices. We don't need to have warranty costs. Do we need to think about asset maintenance?
Well, asset maintenance will give you returns on investment. Either you have significant number of devices, or if your downtime costs are significant, or the third option could be that you have limited number of devices, but the number of sensors on those devices, such as an aircraft engine, the number of sensors is high, and the data points that you're getting from those sensors is significant volume. And definitely those sensors and the data coming from those sensors can provide you insights. And sometimes aircraft engine manufacturers will provide you insights because they do consume the data in real time, but they don't provide insights on every sensor. So you could analyze the insights from sensors where aircraft engines providers are not doing, or where sensors are giving you real-time data.
So we seem to have a question from one of the attendees, Mr. Sean D'Souza. You're on the line now.
Hey, thanks for the webinar. Well, my question was, does simulating warranty cost for predictive maintenance increase warranty cost or decrease warranty cost?
So, okay. Now, when we did it for more than 450 turbines, what we observed is that out of those 30 had a decreased warranty cost, and approximately 400 or so had increased warranty costs. Now, it doesn't mean that the warranty cost will always increase. In other words, it doesn't mean that unplanned outages will always increase because you do predictive maintenance. So it depends on your historical data. It depends on the statistical distributions that you have. And it also in warranty cost based predictive maintenance model, you also do generate a few random numbers. So it also depends on the population of your random numbers in that case.
Yes, that does answer my question.
So we have another question over here via chat, which asks, when do we use optimization models to schedule maintenance? So what are your thoughts on that, Vinay?
So again, maintenance optimization is beneficial when you have significant number of devices or when you have significant number of work orders. And also when cost is a concern, and when there are trade-offs, you want to maximize the uptime, but you also have to stick to rules, and you have to follow certain maintenance schedule. So again, optimization should only be followed when there is you are expecting good return on investment, because optimization models take some time to be built. So you should do it only when you have a high number of devices or the return on investment is significant.
Well, it seems like that was about it for now. So thank you so much for joining us today, and we really hope that this webinar has helped you get a better understanding of predictive maintenance and its implementation. The recording of this webinar will be shared with you in a couple of days. But meanwhile, if you have any feedback or unanswered questions, please contact us at feedback@iNatrix.com, and we would be more than happy to answer your queries. Thank you once again, and have a wonderful day ahead.